Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to the video, and today our problem is less time to buy and sell stock. Now this is supposed to be an easy problem, and it was one of the first problems that I actually did when I started doing DSA way back in college, and I still think it is one of my favorite problems because it is more of the front page problem when it comes to two-pointer approach. So without any further ado, let's get straight into the problem and let's see how we can solve it. So you're given an array prices where prices I is the price of a given stock on the add day, and you want to maximize your profit by buying that stock on a particular day and selling it on another day in the future, and just return the maximum profit you can ever obtain when you're given a set of prices on different days. So for example, this is your array where your prices are given to be 7, 5, 3, 6, 4, and you want to return 5 because as you can see for this particular array, you'll get the maximum profit if you buy the stock on second day where your price is 1, and you can sell it on the second last day and get the result to be 6, which is your selling price. So at the end of the day, you'll return a profit of 5. So the construct is simple. I hope you understand the problem. Let's go straight to the whiteboard to understand how we can solve this. So let's draw out the problem right here. So you're given an array 5, 1, 3, 6, 5, 4. I don't exactly remember the values, but we can just work with this. Whatever. It's not. I think the answer is still 5. Only the indexes are a bit different, and we don't have to worry ourselves with a particular index on which you buy the stock and on which index you sell the stock. You just want to return the maximum profit potential using a single transaction in this particular array. So you have to return 5 here, which would be the difference between your value, your buy value, and your sell value to maximize your profit. Now, when you just came across this problem and you have just started DSA, one of the simplest ways to do this, which would be a brute force approach, would be to go to each element and then go in front of that element and compare its value to all of the other values in the array and see what is the maximum profit you can get if you buy on that day. And this way, you will also maintain another variable, which is your max profit, and you're going to keep updating it on the basis of these iterations. And finally, in one of these iterations, you will have the case where 1 and 6 will come and your max profit will be updated to 5, which is your answer. So this solution works, but the only problem is that for each iteration, you are doing your iterations like this, where your first iteration is n minus 1 times, second iteration is n minus 2, and you will keep doing it unless you are at 1. And if you see this mathematically, you are basically doing the operation n into n plus 1 times divided by 2, which is your O(n) square solution. So we can do better in this problem. It's supposed to be a linear time solution, and let's see how we can use two pointers to actually achieve that. Now, one thing to keep in mind is the fact that we are given in the problem that our sell pointer should always be higher than our buy pointer. Now, why have I quickly started calling them pointer? Well, majorly because of habit, but here the reason is that you can think of this problem as more of a selection problem where you are supposed to select two different days. One is your buy day and one is your sell day, and you have to satisfy two conditions. First is that your sell should always be greater than your buy, and the second condition is that you will only make profit when your value at buy is actually less than your value at sell, and only that way you can actually make any profit, and that's only when you will want to update your max profit value. So those are the two different conditions you have to maintain to get your answer. Now, by using this kind of a brute force solution, which we are not going to code up in this video because I think it's extremely straightforward and you can take it as an exercise because you might have just started learning Golang, and it will be a good exercise to see if you are able to traverse the arrays properly or not. But this particular solution, you can see that we are using the fact that sell should be greater than buy, because in the first iteration we only go through the n minus 1 values, in the second iteration we only go through the n minus 2 values, and so on. But we never use the fact that our sell should always have a higher value inside of it than our buy pointer, and that's why we are doing all of these redundant steps. If we somehow maintain that invariable where whenever we see that our sell is actually smaller than our buy, then we don't need to do any iterations because we want to buy on that particular day. So the first way to think about the problem is thinking that how you can use all of the information given to you, where you will only make profit when you are when your sell is actually higher than your buy. And the second way to think about is that whenever you see a sell that is smaller than your buy, you will want to buy on that day. So general stock market forms that if you know that if you buy the stock today, you're going to get it in 5 rupees, and if you're going to buy it tomorrow, you're going to get it at 1 rupee. So you'll always prefer the 1 rupee rate because that's cheaper for you and you can potentially make profit out of it in the future values. So that's what we are going to do. So we are going to initiate two different pointers. One of them is going to start at the 0th index and the other one is going to start at first, and we are going to keep uh, traversing the array using our sell pointer, and we'll update our buy pointer anytime we see a value where our sell pointer's value is actually less than our buy pointer's value. And the sell should always remain greater than buy, which will be maintained by our traversal and our instantiation. And also, we will always be maintaining the fact that whenever we see a sell which is smaller than our buy, we quickly remove all of the iterations we would have to do in the unoptimized solution, because we know that all of those iterations are waste, because the maximum profit we are going to make is from this smaller value we are seeing in the future, and we are maintaining the max profit as a separate variable. So in that way, even if the max profit was to be made with this value, because we had a higher value right here, let's say 15 or something, you would have already updated it and you will not have to worry about it in the future. So that way you are maintaining all your variables correctly and you only care about the max profit. So one more thing I've noticed is that whenever you have faced the problems where you have to just return the max profit, you just have to return the minimum of iterations or something like that, it's mostly better to think of a problem into just trying to find those maximum values. As generally as we try to think of the indexes first that will give us the best values. We try to find those indexes and then we try to find the maximum profit from there. But in coding, it's more of a waste in compute, where you are also trying to figure out what are the indices that made this profit, and it's actually better to just iterate through this kind of a optimized fashion and just keep store of the maximum value you have seen till now, and that will become your final answer. So you want to go through all of the elements inside of your array, but at the end of the day, what matters to you is just the maximum profit you have seen by traversing the array, rather than what indices that value was on. So I hope the explanation made sense, and let's go back to the Leetcode website and call this solution up. So as we discussed, we first want to instantiate a buy pointer which will start at 0, and then we want to instantiate a sell pointer that will start at 1, which is a higher index than our buy. And we're also going to maintain a max profit which we are going to instantiate at 0, because that's what's given to the in the problem, that if you cannot achieve any profit, you just want to return 0. So after this, we are just going to keep iterating using our sell pointer till our sell pointer is actually less than len nums, and the nums here is prices. All of the previous problem, the array was nums, that's why I'm habitual to it nums. But your sell pointer till it is less than your len prices, you're going to keep iterating and you're going to have an increment for this as well inside the array, but the increment is going to happen at the end. So we are just maintaining this so that we are sure that we never miss our for loop and turn it into an infinite loop for some reason. So here you want to check that if your prices at sell is actually less than your prices at buy, in that case, you, as we discussed, you want to update your buy to be your sell, and that's it. That's what you will do. But in cases where your sell is actually greater than your buy, you want to update your max profit. Now we're going to do this first, because what we are doing is we are setting up the sell value and it's going to be overwritten by buy. And every time we are overriding the value by buy, overriding the buy value to be the sell value, in the very next step, the sell should be incremented to the next pointer, because in that way we maintain that invariability that our sell is always greater than our buy. So before checking that, we also have to check that if prices buy is actually greater than prices sell, In that case, we are actually making a profit. So we want to check that if our max profit is less than prices sell. Oh, I just did this. Sorry. So it's supposed to be greater than. So our prices sell is greater than our prices buy. That's when we are making a profit. So in cases like this, we are just gonna replace this with that, and we are just gonna check how can we update our max profit. So our max profit, if our prices sell minus buy is greater, is gonna be prices sell minus prices buy, and finally we're gonna return our max profit, and that's gonna be a solution right there. So let's try to run this to see if everything is working or not, which it hopefully should. Yep, it does, and we are just gonna submit this. Cool. So it is accepted. It beats 100% in runtime, and in memory we get 65.07%. And we are using constant memory, so it shouldn't be an issue. And also, our runtime is linear, so that's why we are getting 100%. And that's the solution. I hope you enjoyed this problem as much as I used to enjoy it when I first did it. And see you next time. Bye bye.